Hey tech innovators, do you know or have you wondered the companies like Instagram, Apple, how they release their updates without disturbing the users? So this is the magic of deployment strategies. So deployment strategies ensure smooth updates, zero downtime and happy users. So in this video, we'll be diving into different deployment strategies, knowing about how different companies uses different deployment strategies to deploy their codes, and we'll study about how you can successfully deploy your codes into different environments. Let's deep dive into the deployment strategies. The first one is rebuild or recreate deployment strategy. It's one of the very basic deployment strategies, but yet effective. So what we do is, in this deployment strategies, first of all, what we do is we shut down the old version of application completely. The new version is then deployed and then the whole system turns back on. So this means we'll have a downtime. You can see that. Okay, so there would be a downtime where the older software has been shut down and new one is booted up. So it's one of the cheaper options, because what we do is we are completely shut downing the servers and then putting up or installing up the newer versions. So this is what it is. So it doesn't require the load balancers because we are not shifting any of the traffic from one version to another version in the live production environment. But there is a catch. This strategy deployment can have bigger impacts on the end user because it has a downtime. So what you're doing is you're simply taking out the older versions and putting down the new versions into it. So they have to wait for the applications to go live again before they can use the software. So many teams use this strategy and for smaller build-ups, generally when they need to test their applications and all. Okay, now let's see about different pros of this deployment strategy. So here are the advantages. The first one is the simplicity. So if you see, the process is very straightforward and does not involve any of the running of multiple versions simultaneously. So what you do is you simply remove the older version, put the newer version and restart your servers. So that's very simple. Second, it's resource efficient, which means only the one version of the application is active at any time and it's saving the resources. The third, easy rollback. So if something goes wrong, you can revert back to the older version, very simple, and you don't need to manage multiple versions of it. The last pros or the advantage that I can think is the consistent environment. So it ensures that all the users experience the newer version simultaneously. This has certain advantages. Now it also has certain disadvantages. The disadvantages is it has a downtime, which means the application is completely unavailable during the transition, which may impact user experience. Second, risk for critical systems. So if I need to make my system highly available, so as it has a downtime, can lead to significant losses. The third is lack of real-time testing. So there is no gradual rollouts coming out. It has an issue of new versions and can affect all the users immediately. So that is how it is. Now talking the use cases where it is majorly being used. Initially it is used for internal applications where you need shorter downtime, okay, where your systems are very small. You can have smaller build-ups. If you have non-critical updates, you can simply work with these strategies. Third, if you have been working around different or frequent use testing and staging setups, you can use this kind of deployment strategies. If I want to summarize about rebuild and recreate deployment strategy, it's nothing but removing the older versions, putting up the newer version and restarting your machine. Okay, it has a certain downtime because if you see, it takes a time to take out and take in your softwares into your servers. So the user might experience downtime, and that is what the main disadvantage of this. So the second one is the most popular blue-green deployment strategy. So in this deployment strategies, what we do is we involve in maintaining two separate environments. One is known as blue environment and the other known as green, and they are both identical. So it would have the same set of servers, same set of GPUs, CPUs and all the configurations that we need. Okay, so the blue environment is nothing but as a set of servers which would have the current live system and where user would be interacting with. The second is the green environment that you can see into the green color, where we would be deploying and testing the new version of our applications. So what we do is, in this blue-green deployment, what we do is we have both old and new versions of the software running side by side. So you might also know it's a red-black deployment strategies. So what we do is, suppose we have one of the environments like the blue environment where our older application is running. So our load balancers would route all the requests of users to this blue environment. Now, if I need a new version, what I'll do is I'll create the identical environment with same set of servers, the same set of configurations. Now, what I'll do is I'll say my load balancers balances to divert the user request to the newer version of the servers or the configurations that we have, where we have deployed the new versions. So what we'll do is initially it goes 10%, 90% diversion, 20%, 80% diversion. So what we do is we divert 10% to the newer version, 80 to or 90 to the older versions. Then again 20% into the newer version, 80 to the older version. So that is how we balance it, and till the 100% diversion is not done, we never stop this incremental process. So we have two identical environments, blue and green, where we have a load balancer which balance the load of the request coming to this servers. So that is how it works. Now talking about the advantages that I can see is, so the first advantage, if you see, we have the zero downtime. So user experience no interruption during the updates, as we have the load balancers which manage the load between the newer version, which is the newer servers, and the older servers. So which is where you find zero downtime. Now the second advantage that we can see is safe rollback. So if any issues have been done into the green environment, the newer version, we can revert back to the previous version in a second. So what we can do is I can say load balancers, don't divert the new traffic to the newer version or newer servers that we have created. Keep as it is to the older versions or the older servers. Okay. Also, it gives the advantage of real world testing. So green environment allows you to do thorough testing under the production line conditions. Okay, so what you can do is, you can see as we have blue, which is the older version or the older set of servers, new, which is green, which has a newer version deployed and a newer set of servers into it. Okay, so if there are any of the issues coming into the newer version, that is the green environment, we can divert our load balancers request to the older version. So that is how you can have it. So it has a easy, safe rollback, and we can have a real world testing coming up. Also, it supports continuous delivery, means it supports rapid and frequent releases, which deals with the agile workflow that we have. Now, as this strategy has advantages, it also have certain disadvantages that you need to know. First of all, it increase the cost, because as we are creating two identical environments, right, the same set of servers into two different things. Okay, so managing servers, or if you see managing different kind of servers across the multiple environments can create the thing. So maintaining two identical environments requires double the resource, which can be expensive. Second, it might be complex, because syncing between two environments and managing the two environments might be a stress, okay, and can be a technical challenge. Also, for the large-scale distributed systems, maintaining dual environments might not be practical. So many a times we see about the use cases. So if your use cases is to build an e-commerce platform with zero downtime, and we can use this deployment strategies. Okay, and the second use case I can think of critical applications. So system like healthcare or banking, where availability is crucial. We can think of this kind of deployment strategies because it has zero downtime. It also has the safe rollback, and you have two identical environments, so you can switch around the environments very easily using your load balancers. And also percent by percent you can divert your users from the newer environment, or from older to newer, or newer to older, depending on the versions that you are deploying. Okay, it also has been used for SaaS applications. So if you have your SaaS applications where you need a seamless user experience during your feature rollouts, you can use this kind of deployment strategies. Also, if you want to practice CI/CD pipeline, that is continuous integration and the continuous delivery, so for this, it's the best strategies that you can look for. So we discussed about blue-green deployment strategies, which had the very powerful strategies, and it delivers the seamless updates between the different environments and with the zero downtime, and it also ensures user satisfaction. So yeah, so this was the blue-green deployment strategy. So the third one is rolling deployment. It's again a very powerful strategies used by many companies, because it releases incremental and it increases in the incremental fashion. Okay, so it also covers certain pros and cons that we're going to see, but it's most effective deployment strategies. Okay, so let's start with the rolling deployment. So in this approach, what we do is we update our rollouts incrementally to the proportion of servers or the instances of your environments, okay, rather than going all once. So in blue-green, how we had two different identical environments, and we used to shift our traffic based on our load balancing, okay, based on our use cases. But in this, what we'll do is we'll roll out our updates of newer versions incrementally proportion to our servers. For example, if you have have 10 servers, or let's keep it over year 3, okay, and you want to update any one server, you can do it at a time. So what we do is, so for example, if you see over here, we would be having certain servers. You can see where we have 3 numbers, okay, where I have load balancers. So if you see server 1 has version 1, server 2 has version 1, again server 3 has version 1 of the code. What we do is we incrementally update our servers, okay. So suppose server 1 has version 1, what we'll say is load balancer, please divert this load to server 2, and over time, for a time being, we'll downtime server 1. So what we'll do is we'll change this to version 2 of our code. So the our server has been updated. Now what we'll do is we'll say, okay, load balancer, please divert the user to the server 1 with version 2. Now we'll come to server 2, where we'll update the version 1 to version 2 of our code, and again we'll say, please divert the user to server 2. Again we'll shut down the request to the server 3, and we'll say, please update server 3 with version 2 of our code, and then we'll bring back the user to the server 3. So in this deployment strategies, you see we're rolling out the updates based on the servers one by one. So the key advantage that I can see is minimum risk. Since we are updating rollout in the stages, server 1, server 2, server 3, it's easier to detect and address issues earlier before impacting all the users at once, okay. So what we do is we'll stop the server 1, we'll update it to version 2, we'll send some set of users to server 1, and if we see that version 2 is not working properly, we'll just shut down the server 1, and then we'll keep server 2 and server 3 as it is with the version 1, okay. So it creates the high availability, so your application remains live throughout the deployment process, which means no downtime for the users, okay. Now the third advantage that I can see is, unlike blue-green deployment, this method does not require duplicate environments, so that saves your cost, reducing infrastructure cost, and it also saves your time to manage multiple servers, multiple instances at a time, okay. So the fourth advantage that I can see is it's scalable. It's well suited for the large scale applications, especially in the cloud environments. Now the disadvantages of rolling deployment. The first is slower deployment type, because updates take longer time since they are applied in the stages. So the stage 1 of the server 1, stage 1 of server 2, stage 3 of server 3. So what we do is we shut down the server 1, we update the version 2, then we shut down the server 2, we put the version 2 into it, we shut down the server 3, we put down this version 3 into it, and then if you see, it is updated into incremental fashion, so it has a slower deployment time. The second disadvantage that I can think is temporary inconsistency. So for a shorter time, some user might be served by servers running different versions. So if some users, as we are diverting the users from server 1 to server 2 because server 1 was closed, as the server 1 was closed or it was not working as we were updating it. So for a shorter time, some users might be served by servers running different versions, which could lead to the issue of versions, and we can't go backward to it, okay. The third disadvantage that I can think is complex monitoring. Tracking and managing the update progress across multiple servers needs the robust monitoring tool. So what we do is we are shutting down the server 1, putting the newer version into it, okay, monitor it whether that version is working fine or not. If it's working fine, we'll divert our request back to the user. Now again we'll shut down the server 2, which has the older version v1 of code, put the newer version v2, again bring the traffic to the server 2. Same, we'll shut down the server 3, put the newer version into it, and bring back the traffic to version 3. So if you see, what we're doing is into incremental fashion, and it might have a slower deployment time depending on your server configurations, as well as it might have complex monitoring, because you need to monitor each and every server how it's working depending on the request that you're getting from your load balancers, okay. Now talking about the use cases, so most of the companies uses this kind of rolling deployment strategies compared to blue-green depending on the application type. So if your application type is cloud-based or cloud-native, so it works well when you have dynamic environments like AWS or Kubernetes. So this is the best deployment strategies that you can think of. If you have large distributive systems, so if you have a system with 100 or 1000 instances, it allows you the safe and gradual updates. So that is what it goes. Also, if you have frequent updates coming up, so if your team follows a continuous delivery pipeline and this approach ensures the incremental and reliable rollouts, this is the great strategies that you can apply for. Then if your application has the high traffic, so this application where you have zero downtime, and where downtime is not acceptable. This deployment strategies are useful for e-commerce platform, again for streaming. So this was our rolling deployment strategy. The another deployment strategy is canary deployment. So canary deployment is nothing but what you do. We have certain servers. So what we do is based on region. Suppose if I have to just update the version of a region, South specific or Europe specific, I'll update that server based on that. Okay. Then it might be a user specific, where certain 10-15,000 users, or depending on 10 to 5% of users, should be applied for this version where I can update that server. So now let's see to the diagram where you can see that we have servers coming up. We have load balancers. What we do is let's talk about user specific. Okay, so let's take a smaller amount of users, like 5%. So if I have the server 1 which has the older version v1 into it. Okay, now what we need to do is we need to update it, as we need to deploy a new code. So what we'll do is I'll gather that 5% of user, I'll update my server 1 to the version 2 of my code, that is the newer version, and I'll just divert the 5% of user to the server 1. Rest 95% of users would be going to my server 2 and server 3. It might have servers depending on your use cases. So the other servers other than server 1 would have version 1 and version 1 only, the older versions. So you can see here I'm updating based on the smaller amounts of the users into it, and it is user specific. If this server 1 accepts, or the user accepts the version 2 and it goes good, incrementally I'll update server 2 with version 2, or same server 3 with version 2, and I'll use load balancers to divert the traffic among the servers accordingly. So if initially it had 5% traffic going to server 1 which had version 2 updated, rest 95% were into server 2, server 3. Now what I'll do is incrementally I'll increase the users, like from 5% to 10%, 10 to 15%, and accordingly, if you see, I'll update also my servers based on it. Now let's talk about region specific. Suppose I have server 1 which had version 1 into it and which is specific to Asia. I have server 2 which has version 1 again with Europe region into it. I have server 3 where it has version 1 of code which is related to the US region. Okay, now what I'll do is I'll update my server 1 and say load balancer to divert the traffic of only user Asia specific. So the Asia specific person would get diverted to server 1 which would have the newer version v2. The rest of the servers would have the version 1, like the person from Europe or the people from Europe or the people from US would get version 1 of the code, okay, or the version 1 of your application. Now if the server 1 works fine, if the Asia people are been satisfied with your newer update, what you'll do is you'll update server 2 which was used by Europe, so you'll divert the Europe traffic to server 2. Talking about server 3, same, if the version 2 you updated to server 3 which was US region specific, you'll divert the user which is US specific to server 3. Now if you see, this is the strategy region specific. So depending on the regions, you're updating your servers or the deployments based on the regions, how it goes, and that is how you generally divert your users to different servers, and that is how you can manage the new updates in the real world environment while minimizing the impact of your issues. Okay, now talking about the advantages, what I can think of, it's early feedback. Okay, so as we have been opened certain percentage of user to accept the newer version, so we'll get an early feedback. So if issues are detected early from a smaller user base before they affect everyone, we'll get the faster feedback and we can work it. Talking about the second advantage is real world testing. So it provides valuable insights into how newer version performs into actual conditions. So if you have a region based deployment, so if server 1 had Asian based deployments, server 2 has Europe based deployments, so based on the traffic coming in, based on the feedbacks coming in, you can do the real world testing and it would provide the valuable insights for you. Now third advantage I can think is risk mitigation. It limits the blast radius in the case of bug or failure, because as we have just given the smaller user base or smaller region to accept our new version, okay, so if the newer version performs well, the deployment might expand based on the user's feedback or based on the system, how it works with the newer versions of our code. Okay. The fourth advantage is scalability. So it's majorly perfect for the cloud-based or microservice-based architecture where changes can be applied incrementally. Now let's talk about disadvantages. The first disadvantage is complexity, because as you are incrementing and managing the canary deployment requires additional monitoring and automation system where you need to monitor the users first of all, as you are diverting the users based on certain percentages or else region. So you need to monitor region wise as well as user wise. So it might be complex and you need to have proper monitoring systems. The second disadvantage that I can think of is temporary inconsistency. So users may experience different versions simultaneously, which can lead to potential confusion. As we are selecting specific users with a specific region, so it might be confusion for some users to get newer version of your application. Some would get the older version of your application. So that can create a confusion. The third disadvantage that I can think of, resource overhead. So you need to have additional infrastructure may be required to handle parallel versions. Okay. So if you have server 1, okay, which had version 1 into it, okay, and you said around 5% should get diverted to the version 2 of server 1. Now, what rest 95% of user would do? They might get diverted to server 2 or server 3. So that can be the thing. Or else let's talk about region specific. Suppose you have server 1 which was specific to Asian region, and you diverted the traffic to Asian person to server 1 with newer version of code v2. And if the whole community of Asian countries are facing issues with version 2, that can create problems. So you need to handle it with parallel versions coming up, with parallel servers coming up. So that can create a resource overhead. Now let's talk about use cases, because as this has certain advantages as well as disadvantages, many companies also practice this kind of deployment strategies like canary deployment, where we need feature rollouts. So if I have the perfect testing environment and I need to roll out new features with a smaller audience before a full-scale release, I can talk of canary deployment. So many a times you have seen gaming industries, Valorant, Counter-Strike, as well as, so they just focus on the smaller scale of people, they test it on that scale or the gamers, and then they roll out the whole updates. Second, if your systems are bit critical, so this is ideal for the applications where you have a critical systems coming up. So where the downtime or failure could have a significant impact, like financial or healthcare platforms. The third use case can be user feedback driven. So if you want to take out the user feedback and then work on it and then update your versions, that's the great thing. So if you're taking the feedbacks as it's a user specific or region specific, you can take the feedbacks from them and apply it and again update your server accordingly. So these are the use cases of canary deployment. So let's come to the end now. Let's have a conclusion about the deployment strategies. So in this video, we learned about different deployment strategies. We started with the basic one, which was rebuild or the recreate deployment strategy. We ended up with the complex one, that is the canary deployment. Every deployment strategies has certain advantages, disadvantages, and also we saw about use cases. So hope so this video was useful for you to know about deployment strategies. And till then, keep learning and keep growing.